Global warming is one of the most subtle yet dangerous threats to our Earth today. According to the National Oceanic and Atmospheric Administration, the Earth's surface temperature has risen 1.33 degrees Fahrenheit in the last 200 years, which doesn't sound like a lot, but when you consider the rate at which this is occurring, almost doubling in the last 50 years, the potential for damage becomes a lot larger. It's been observed there is a direct correlation to extreme weather patterns to the increase in temperature around the Earth. Now today, we are going to find out how is humanity's use of combustion reactions affecting climate change, and how can we reduce this damage. Today, we're going to be testing an experiment to discover the real impact of climate change. We are using a controlled environment, testing different gases and seeing their effects on temperature.
Before we get started, we have come up with 3 possible outcomes, or hypotheses, that we believe could be the answer to the first part of our driving question, which is how is humanity's use of combustion reactions affecting climate change? Our first hypothesis is that combustion reactions are dangerous to climate change because of the heat they directly produce. This would make sense because regions with frequent forest fires have typically hotter and drier climates than areas without them. The second hypothesis is that it's not the combustion reactions at all that are causing the damage, but rather the way we obtain the fuels to create them. This would also make sense because frequent breaking of major ice fields, oil drilling in the ocean, and mining to obtain minerals cause damage to the environment and can affect regional climate. And finally, our third hypothesis is that it's something the combustion reactions create that is causing the damage. Now let's get on to figuring this out.
Over the past 200 years, humanity has started to use fossil fuels, and accordingly, climate change has become a problem. Fossil fuels are just another name for a hydrocarbon. An example of that could be oil, natural gas, or coal. And they're all substances humanity has used in their industrialization to fuel their cars, to heat their houses, and in industrial production as well. When used, they release something known as greenhouse gas. An example of that could be carbon dioxide, methane, nitrous oxide, and fluorinated gases. Some of these gases end up in the ocean, but occasionally they end up in the Earth's atmosphere, and that's when problems start occurring. The atmosphere of our planet is one of the key reasons why life can survive on our planet and not others in our solar system. Our atmosphere regulates our climate, and a balance of nitrogen, oxygen, and other gases help entrap enough heat to keep our planet habitable, but also release enough to the space so that it doesn't overheat.
So, now we have some evidence that humanity's use of fossil fuels is linked to climate change. We still don't know exactly how they produce greenhouse gases. I mean, how come these fuels didn't emit these chemicals during the millions of years that they existed in the ground? Well, it's because in order for humanity to use fossil fuels, we need to put the molecules that make up the substances through a chemical reaction.
When humans use fossil fuels, they are using a combustion reaction to separate the carbon and ultimately release energy for us to use. Combustion, as mentioned earlier, involves the burning of hydrocarbons. Combustion reactions occur when a reactant comes in contact with oxygen and can produce carbon dioxide and water. It also, as mentioned earlier, usually in the form of fire, produces light and heat. Another example of a combustion reaction is the burning of methane, in which 2 diatomic oxygen molecules combine with methane to create the products of carbon dioxide and water, along with some heat and light. This is a reaction mainly used in electricity production and domestic stoves. Another type of combustion reaction is commonly used by humanity is the reaction of gasoline, in which pure oxygen combines with gasoline to create carbon dioxide and water once again, with heat and light. This is a reaction that is one of the biggest offenders in producing harmful greenhouse gases, as used to power most vehicles with internal combustion engines. Looking back at all the evidence we have shown you, it suggests that the combustion reactions created by the burning of fossil fuels release harmful gases into the atmosphere, such as carbon dioxide. So in conclusion, the evidence does point to our third hypothesis, which is the one that stated that the products of combustion reactions have the biggest impact on climate change. In hopes of understanding greenhouse gases and their relationship with temperature, we conducted an experiment involving 2 of the most prominent greenhouse gases, methane and carbon dioxide. What we did was create 3 identical greenhouse boxes, which all represent our atmosphere, and placed identical ice cubes on trays within them. One of our greenhouses contained high levels of CO2, another methane, and one with the control had just normal atmosphere. The point of this experiment was to show just how much temperature can be affected by these gases. In order to get accurate results, we made sure to use both a light meter to make sure the amount of light entering the containers was consistent, along with sensitive thermometers to measure the subtle temperature changes.
Following the steps of the scientific method, we had questioned, posed hypotheses, designed an experiment, and now we were ready to record and analyze, and then revise. On our first attempt, we tested all of the greenhouses together under a 12-watt LED bulb, which did not produce effective results due to the lack of heat. Our second attempt was with an 100-watt bulb, which also failed due to a lack of equal distribution of the heat, along with still lacking amounts of power and CO2. When we tried it a third time, we used an 150-watt bulb, more CO2, and tested the gases separately, so we were convinced that this would be the time that would work. And it did start off pretty well, with the methane and air containers reacting as expected. But surprisingly, our carbon dioxide container actually began to lose heat. We soon realized this was because a reaction of baking soda and vinegar was endothermic, meaning it was taking more heat energy from the air than the carbon dioxide could trap in. In order to fix this, for our fourth experiment, we did our acid-base neutralization before we put the ice cubes in, and finally, we got the results we were looking for. The greenhouses with CO2 and methane's ice cubes were nearly fully melted after only an hour, where the air ice cube was only about half melted, along with the methane greenhouse having a final temperature of 1 degree higher than the others. Looking at this, and the evidence we mentioned before, we can confidently say that although all of the hypotheses have truth to them, hypothesis number 3 is the most accurate, which stated that it's not really combustion reactions at all that are causing the damage, but rather it's the products that they create.
With the evidence presented, it seems quite clear that humans are causing global warming with their combustion of fossil fuels. As kids, it is easy to think that we cannot do anything to right the wrongs, but that could not be further from the truth. After conducting a survey, as much as 75% of kids don't go out of their way to help the planet, even though they believe in climate change. You can change that with your everyday actions, however. Walk to school, reduce your waste, and most importantly, bring awareness and a commitment to our planet to others.